Hello, everyone. We are going to be starting our Unit 6 curriculum today. And so before we get started with that, I thought we would do a couple of problems to review Pythagorean theorem. So here's your warm-up. You're going to need your notebook today, and you will need a calculator. So get those things handy. If you need to pause the video, do that, and get those things ready to go. For your first two problems, you're going to find the missing side length of each of the right triangles so you can see where they're missing. Pause the video, draw a sketch of each triangle, and show all the steps to solve the problem. And you should pause the video now. And welcome back. Here are the solutions. So for the first one, we can see here that the right angle is across from the hypotenuse, and that's what we're looking for. So that means we square the legs. 8 squared is 64, 6 squared is 36, and then we add them together. 100. Square root of 100 is 10. So check my work. And 10 feet is the correct answer. And then for number 2, it's a little bit different because we're looking for this short leg right here. And so that means that we square 15, the leg, which is 225. Then we square the 17, the hypotenuse, and get 289. But now this time we subtract because we want to know the length of this leg. So subtracting 289 minus 225 will give us 64. Remember that you have to take the square root of that number to get your answer, and so we end up with 8. Let's check. And the correct solution is 8 centimeters. So starting with this unit, we are going to be looking at representing geometric sequences as exponential functions. That's what we're going to be looking at first. And we'll be looking at tables and graphs, equations, and verbal descriptions for all of those. So your homework for today is going to be to complete problem 1.2. We're going to do a little intro to that, and then you will answer the questions through a Google Doc for problem 1.2. So, a couple things that we're going to look at is when we're thinking about an exponent. So, if we're talking about an exponent, I'm going to type one in here much larger. So, if I had 5 to the second power, that is in exponential form. And so the parts to this are the exponent, which is the 2, and then we have the base, which is the 5. You should have your notebook out and write that down for the exponent and for the base so that you can see which one is which. So there's the base and there is the exponent. We'll keep referring to those. Now, when we talk about something in standard form, that means that when we evaluate that, you can see that right here, 2 to the 5th power, opposite of what I did here. 2 times 2 times 2 times 2 times 2 is 32. So we say 32 is in standard form, where we have evaluated that. We have taken it from expanded form, and that would be expanding it out, okay? So I want you to look at the questions I have here, and you're going to write each expression in exponential form for the first 3. Then you're going to write each expression in standard form. And then you'll go through and answer these next 2 questions. So if you need to pause the video right now, you should pause. So pause the video if you need to. And I'm going to go on to the next side for the actual answers. So looking at the first part, 2 times 2 times 2, that is 2 to the 3rd. So we're writing that in exponential form. 5 times 5 times 5 times 5 is 5 to the 4th. So that would be exponential form for that. And then part C is 1.5 to the 7th power. Now looking at our expressions in standard form. So I expanded the 2 to the 7th power, but then the other thing that I can do with this, since I'm writing this in standard form, is I can tell what it's equal to, and 2 to the 7th power is equal to 128. 3 to the 3rd power is equal to 27. And then 4.2 to the 3rd power is equal to 74.088. The next part talks about the calculators that have a little caret key or a y to the x, and we've used both kinds, so it depends on what kind of calculator you have at home to evaluate expressions. So when we look at this problem here, 2 to the 15th, you might use this button right here. You would put in 2 and then use that button and then the 15. Or you might use the y to the x. And so either way, what you would type into your calculator would be, you would type in 2, and then you would hit that button that either looks like that or the y to the x, and then you put in the exponent 15, and then you hit equals. And when you do that for this first problem, you get 32,768. Part B is 59,049, and part C is 3,325, and that's 0.25673. I didn't round it because it was a terminating decimal. The last question here says, explain how these three expressions are different. So the first one, 5 to the 2nd, is 5 times 5. The exponent 2 tells how many 5s, the base, are multiplied, and you get 25. The second one, 2 to the 5th, is 2 times 2 times 2 times 2 times 2, gives you 32. That exponent 5 tells how many 2s, your bases, are multiplied. And then the last one is just 5 times 2 is 10. There is no exponent with that. So that's just a review for exponents, or maybe some new material for you for exponents, but all things that you're going to need to know for what we're doing today. So here's the story, and your problem 1.2 is going to build off of this. So one day in the ancient kingdom of Monterec, a peasant saved the life of the king's daughter. The king was so grateful he told the peasant she could have any reward she desired. The peasant, who was also the kingdom's chess champion, made an unusual request. I would like you to place 1 ruba on the first square of my chessboard, 2 rubas on the second square, 4 on the third, 8 on the fourth, and so on until you have covered all 64 squares. Each square should have twice as many rubas as the previous square. So you can see in the picture here. So here is the first square. That's square number 1. This is square number 2, square number 3, 4, and so on. And this is the number of squares, and then down here, the number of rubas. So this one has 1, this one has 2, and then this one has 4. Remember, they double. And then this one has 8, and so on. Okay. The king replied, "Rubas are the least valuable coin in the kingdom. Surely you can think of a better reward." But the peasant insisted, so the king agreed to her request. Did the peasant make a wise choice? So think about that. So I'm going to just type in here that this right here was, we were talking about the number of squares up here, and down here we were talking about the number of rubas that were put on each of the squares. So those are some important things to remember, okay? So this is the end of our video for today. What you're going to do after the video is you will access the second material in our task today, and that's problem 1.2, looking at exponential relationships. You should have a copy already made for you as a Google Doc. You may type your answers right into the Google Doc. if you have access to a printer and you would prefer to print it and handwrite it, that's just fine too. Um, and then there's one question that asks you to do a graph. And so where it asks you to do a graph, what you're going to do is go to desmos.com. And you don't need to log in with this and you'll start graphing. Just a reminder of how we graph points. And so if you were graphing point 1, 1, you have to open your parentheses, 1, comma, 1, close your parenthesis, and then it puts the dot. If you were doing 2, 2, same thing. Now watch what happens if I don't open those parentheses. It doesn't do it, and it gives me that hazard sign. So I need to go back and put my parentheses in there because it's making me put my X and Y coordinates in correctly. These aren't the points that you'll necessarily have from your table. However, I just wanted you to see how you would do this, and then you would take a screenshot of this and attach it to your assignment. To take a screenshot, you can use Command Shift 4, and then so if I do that, you can see now I get this little icon here, and I take it and drag it for whatever I want to take a picture of, and now I have a screenshot of that. So you'll take a screenshot and then you can attach it along with your homework. So if you have any questions, please email me and let me know, and I look forward to seeing your work.